I'll do a little bit of an introduction for our guest speakers. First of all, we do have Mike Thurston on with us, who is the, I believe, the director for the Golisano Institute for Sustainability from RIT. And we have Selena Corcoran, who is the marketing and communications program manager for the Institute. And then our guru for today's program is Ajay Kaladkar, and he is the technical program manager for advanced manufacturing and industry 4.0 solutions. He has extensive experience in this field, and I am confident you will get a lot out of today's program. So with that, I will turn it over to Ajay.
Thank you, Cindy. So I'll quickly share my screen and we can get started. Hopefully you guys see this screen. Okay. So on agenda today, we have a few things and we hope to cover the whole agenda in 45 minutes or so that we have a good 15 minutes for question and answers at the end of it. We'll start with Industry 4.0 definitions and overview. We'll step through why should we care about Industry 4.0 and what advantages it gives you. We'll cover how can RIT assist with Industry 4.0, and there are a couple ways we can assist. We'll go through a case study on how one of our customers started their Industry 4.0 journey and are on their way for an Industry 4.0 transformation. We'll cover an MXD engagement opportunity that is that has recently come up. So without further ado, what's Industry 4.0? So the official definition is this: current trend of automation and data exchange in manufacturing technologies, including cyber physical systems, the Internet of Things, cloud computing, cognitive computing, creating smart factory. And usually when I say that definition, I've lost folks at maybe the fourth or fifth word in the definition. So here's a simpler definition: widespread integration of information and communication technology in industrial production. And in a single word, it's digitalization. So if we were to use a popular internet meme to describe Industry 4.0, it would be this, where IT merges with OT and you can't distinguish one from the other. So by IT, we mean digital software systems, business intelligence, data analytics, all that kind of stuff. And by OT, we're talking about physical assets, machines, process technology, products, people, all the physical things that make your shop run. So a question may arise, why exactly are we calling this 4.0? So here's a graphic that explains the 4 industrial revolutions on a single screenshot. The first one started when we actually had some mechanization using steam power, and that was back in 1700. The second one was when we started using mass production with help of assembly lines. And of course, the most well-known phenomenon there is Ford Motors, but Henry Ford didn't actually invent the assembly line. He invented a moving assembly line. So assembly lines were around when Ford started production. The third revolution was when we first saw CNC controllers back in 1960s. And now we are in the fourth one. I especially like the bar on the right here, which gives some guidance on how complex those revolutions have been. And one thing to note here is the time between those revolutions is getting quicker. So the last one that we saw was approximately 50 years ago. We took 2,000 years to see the first one. We probably saw 100 years to see the second one. So things are moving faster and we are making higher progress. So what are we talking about? With all the technology, we have the underpinnings of fourth industrial revolution in 3 information laws that have seen exponential progress over last 50 years or so. We've seen exponential progress in data storage capacity. We have seen exponential progress in data transmission capacity, and we have seen exponential progress in data processing capacity. Together, Moore's law, Butler's law, and Crater's law. So everything is doubling every 12 to 18 months, and that's enabled all these wonderful technologies that can enable even better continuous improvement. So we are talking about demand-driven supply chain. We are talking about big data. We are talking about cloud computing, additive manufacturing, robotics, Internet of Things, augmented decision support, digital twins, all those things. And of course, they enable these wonderful things like improved decision making, improved quality, resource productivity, efficiency, flexibility, agility, better customer responsiveness, and transformational value propositions for your business. So let's go through why exactly one should care about Industry 4.0. So we have newer value propositions. We can take our operational excellence to completely next level. And if you have a lean initiative in your plant, Industry 4.0 can pretty much supercharge that lean initiative. So here is a slide that in a nutshell explains that the technological progress has been exponential, and we don't expect our business KPIs to follow the same trajectory. We don't expect our revenue to double every year. We don't expect our lead times to halve every year. So yet technology has grown exponentially, and that has created a potential for disruption. So this first part here talks about newer value propositions. We see routinely companies engaging in sustaining innovation. You have a product, you invest in R&D, you make it better through sustaining innovation. And some products on the slide should be familiar, but technology enables disruptive innovation. So you can have a transformation in how value is delivered to the customer if you have the right people to execute it. So that's one major thing the fourth industrial revolution has enabled. And the core part here we want to cover is how Industry 4.0 enables operational excellence. So I want to begin that part with a story. And the story is set in 1950s, where we had the Korean War. And that was the first major war where we saw jet dogfights. And on the Russian side, they had MiG-15s, and the Americans had the F-86 Sabres introduced in that war. And here's a staggering statistic. The MiG-15s had higher climb rate, they had higher ceiling, they could turn more sharply, they had a better range as compared to American F-86 Sabres. Yet F-86s managed to intercept and hunt MiG-15s in Korean War. Actually, the rate at which F-86s hunted and intercepted MiG-15s was 5 times the opposite. So how was that possible? If you have a better equipment, you should have a better performance in the field, right? So it turns out there is something called as OODA loops. So the key to the victory depends on how well the system, which is individual and equipment, or the organization in our case, reacts to a constantly changing situation. So every leader that is faced with a crisis situation, be it a jet dogfight or be it a manufacturing problem, has to go through the 4 phases of decision making. They need to observe what's happening on the field, which they do by collecting crisis or situation data through information. They have to orient themselves, which is analyze and synthesize data to form their current mental perspective. They need to decide, and determining the course of action based on one's current mental perspective. And finally, they need to act. They need to physically execute the decisions they have made. And many a times, by the time you need to act, things might have changed and you need to restart the cycle by observing, orienting to the newer pieces of information. So the key in Korean War was that F-86s enabled shorter OODA cycles compared to MiG-15s. And that happened because the canopy design for F-86s was much better than MiG-15s. The pilots have better access to information. And that's how MiG-15s were left scrambling to reaction. And here's genius Colonel John Boyd, who is credited with development of OODA cycles. I should say that this slide comes from Dr. John Carrier of MIT. I highly recommend you guys go and look up his videos on YouTube about Industry 4.0 in conjunction with systems thinking. He's great at that. So here are a few OODA loop triggering questions in manufacturing managers. My key customer is requesting 100 prototypes of new product they want to test. Order is due in 3 weeks. Can we fulfill their request? My key supplier just reported an unforeseen shutdown for a week. Can we still keep my commitments to the customer? My HVAC system is down. What actions are necessary to safeguard our investments? A key component of an assembly that's due for shipment in 48 hours was deemed defective. Can we still ship on time? So these are just examples where manufacturing managers are taking in information data points, and orienting themselves and physically executing the decisions. On a daily basis, we go through many of these. So what difference does Industry 4.0 make? Right? So in a traditional factory, you're observing maybe anecdotal information, you're orienting yourself using in-person meeting or hierarchical reports. Your decisions are many times, whether you like it or not, are best guesses, or you're still in a dilemma after you have made that decision. And your actions may need management approvals because there is still quite a bit of uncertainty for critical decisions. So what does Industry 4.0 enable? So you are with a smart factory looking at reliable leading indicators, live data. You are orienting yourself with the real-time data on your shop floor. Your decisions are actually decisions that you have high confidence in, and your actions are seamless. So you don't have uncertainty looming over you once you've made that, once you have executed that action. And that's exactly the competitive advantage. You can make those decisions faster, and you can be much more confident with your decisions. So a question for senior leadership to ask themselves is, if we wish to make better decisions in shorter time frames, where should we invest? Investments in observe, orient, and decide phases of OODA loops are equally important, if not more, compared to the act phase. So a better equipment, a faster CNC machine can give you better acting capability. But it's also important to look at the first three phases of the OODA loop. And that's all enabled with Industry 4.0. All these technologies that we discussed in the previous part of the presentation. So generally, the traditional operational excellence has been pursuing lean. And to quickly recap lean, it begins with defining value. What exactly is your value proposition to the customer? Mapping your value stream, creating a flow, establishing pull, and then pursuing perfection. So that's a set of principles that is targeted towards eliminating waste and delivering to the customers exactly what they need, when they need it, in the quantity that they need, in the right sequence, without any defects, and at lowest possible cost. So how does Industry 4.0 work in conjunction with lean? So you have, maybe 15, 20% of cost reduction using lean optimization. But with Industry 4.0, we believe it can go as high as 40%. And there are many aspects that are highly complementary to continuous improvement. In fact, many believe that Industry 4.0 puts the continuous back into continuous improvement. So you have actual continuous gathering of data through IIoT, which gives a much more comprehensive picture of the shop. Technology allows manufacturers to step through continuous improvement cycles much faster. So here are a few examples that the continuous improvement folks routinely face. I need to gather more information about my process. So sensors and big data can help you do that. I need to communicate more information to my peers and other stakeholders. IoT and communication protocols can help you do that. I need to learn better from the information. So machine learning can assist you do that. I want to try improvements with minimal interruption to operations. So digital twins can help you do that. And I need to make meaningful progress through information. So software integration, augmented reality, virtual reality, all that enables things. And there's of course a few things on the slide. Um, Use of cobots, for example, in complex setup operations can help you achieve the single minute exchange a die style principle in practice with help of technology. Real-time data can help you build a better flow-oriented layout. Uh, there are predictive algorithms that can help you enhance your TPM program if you have one. So there are very complementary things between the two, and we believe having both work in tandem is highly necessary. Industry 4.0 is not reinventing business foundations. I think it's an enabler for taking things to next level. So how can RIT assist with Industry 4.0? So there are a couple of ways we work with customers, and the first one is outlined on in the next few slides. We can help you kick off enterprise-wide Industry 4.0 transformation. And that happens through assessments, through prioritization framework, through a strategic roadmap building. But we also help you start with Industry 4.0 through a problem solving route. And we have a few slides that can help you help you understand how that happens. So here's the framework for the assessment that we conduct for businesses. It does a few things really well. It breaks down the elements of Industry 4.0 for operational excellence into 16 different dimensions. And those 16 different dimensions are related to the building blocks of any organization, irrespective of your business model. So you might be a make to order kind of a business, or an engineer to order kind of business, or you might be a continuous manufacturing facility that's making maybe food. So it looks at operations, we look at supply chain, product lifecycle, automation, connectivity, intelligence, talent readiness, and structure and management. I'll quickly zip through the 16 dimensions to give you an overview of what that entails. So the goal of that assessment is to have a good understanding of the expanse, identification of technologies that can deliver immediate benefits, making progress measurable through a scoring system, because you have these broad set of principles that are applicable everywhere. How do you measure progress? So this gives you a measuring system, and it unlocks the next steps for prioritization and roadmap development. So the first dimension here is vertical integration. Here we look at how your organization is oriented vertically. On field level, you have sensors, actuators on all these machines. Those are connected to your PLCs. PLCs are in turn connected to your SCADA systems or your HMIs. SCADA stands for Supervisory Control and Data Acquisition Systems. MES is Manufacturing Execution Systems. Those systems help you execute the transactions on your shop floor, and ERP, Enterprise Resource Planning Systems, helps you plan for the whole shop. So ERP is thinking in weeks or in months on that time scale, while sensors and actuators are working on actually milliseconds and seconds time scale. So any disruption on either end, say your customer comes in and says, hey, I need you to make 100 prototypes for this new product I'm introducing. Can you make them? So you need a seamless data fabric from top to bottom to understand how your capacity stacks up, and vertical integration can help you do that. So we look at how frictionless is the movement of information through the levels of organization from field to management. And by the way, vice versa is true as well. Where you have your key asset going down, you need to understand which orders in your ERP system can be impacted, and you want that to happen in real time. The second dimension here is horizontal integration. So this looks at how frictionless is the movement of information between key external stakeholders. And those may include suppliers, customers, subsidiaries, all those guys. And our process is optimized through insights generated from analysis of data with minimal human intervention. So again, borrowing from Dr. Carrier, he says, if you're going to market and buying a tomato, you're actually buying a product. But if you are someone that's making ketchup and needs 10,000 tomatoes, you are buying the process on your supplier's end. So you need to understand when that process is going out of control, and you need to understand that in real time. And there are tools that can help you understand those things in real time. The third dimension here is product lifecycle integration. We look at how frictionless is the movement of product information through the value stream. So from cradle to grave, does everyone have access to the right information at the right time to do their job? In a high mix, low volume kind of company, especially, you have thousands and thousands of data points that are needed for a job to complete from start to finish. Um, those may include tooling, gauging, fixtures, CNC programs, recipes, all those things. If there is a common information platform, it takes away the friction between information exchange. Lastly, uh, actually, that was the last dimension for process. Now we enter the technology dimension. And here we look at, are we making the best use of machines, robots, or process automation to save labor? So we look at three different levels in technology areas. We look at shop floor, enterprise, and facility in a different dimension each. So on shop floor, we look at obviously whether you're using robots and cobots to the fullest extent possible to free up people from ergonomically unfriendly tasks. For enterprise functions, we look at whether robotic process automation is being applied for appropriate tasks that are really rules-based and can be automated easily. For facilities management, similarly, there are software systems that can help you optimize the spending you have on many different areas in facilities. So all that is covered through automation. For connectivity, we look at how interconnected the equipment, machines, and computer-based systems are. We want to gather as much data as we can from the equipment we have in the field, so that we have a strong digital shadow. So the data exchange needs to be seamless within all these three functions, and you need to have a good understanding of what's happening on your shop floor in real time. And I would argue that the connectivity is a means to an end, and that would be intelligence, that is using that data gathered to move from a backward view where we are looking at things after they fail and conducting descriptive analytics, to a forward looking where we can predict failures before they occur. So we want to process and analyze data to optimize existing systems and processes to the best possible extent, and that's enabled by intelligence dimensions. Lastly, there are four people-centric Industry 4.0 elements. Your Industry 4.0 program can collapse if you don't have the right leadership and workforce. So we look at workforce development, how robust are your learning curriculums to move from 3.0 era to 4.0. We look at leadership competency, um, how competent your leadership is, how do they have the vision to incorporate technology in company's future. We look at how you collaborate, not only within your company, outside your company as well. Are you making best possible use of the tools available in the market? And finally, we look at the strategy and governance framework that you have. Every organization has one. It's just that the Industry 4.0 era needs newer considerations for strategy and governance. So those are the four people-centric elements. So that completes the assessment. And generally, the assessment is giving you a baseline or where you stand on all these 16 dimensions, which of these dimensions are important to your business, That then gets combined with prioritization guidance, which can help you understand how do the assessment scores relate to my bottom line? What does it mean for my income statement? It looks at your KPIs. So what are my essential business objectives and how do all these things relate to my business objectives? And it looks at broader community of manufacturers and how are they doing with respect to all these 16 dimensions. And that prioritization guidance combines all these elements into one single cohesive framework to give you a clear direction on what your priorities are. What should you work on first to make the biggest impact? So the typical target KPIs can fall into one of these three different categories: efficiency, quality and assurance, speed and flexibility. And there are many things that you can obviously do through Industry 4.0 adoption. And all of these have examples in the market where people have made some transformational impact. So to summarize, once you go through the assessment, once you prioritize things, it's a start of the journey, right? So you have your current state, and just like lean, you know your current state, you know the future state, you identify the gaps, and you make a plan to fill those gaps. So um, the the framework converts things on an objective scale. Where do you stand on a band of 0 to 5, 0 being the lowest, 5 being the highest, and how do you march through your Industry 4.0 journey? So here's the busiest slide I've prepared in my career. Not very proud of it, but it is here to illustrate a point. So there's a lot of busyness in the framework, and there are foundational technologies that enable progress through solutions in the market for your facility. And it's here for a reason, because the solutions landscape is extremely busy, and we assist organizations in selecting the right solution and integrating it. So that's in a nutshell how we propose people that have heard about Industry 4.0 for a long time but want to start in a strategic way should start. And we have the assessment offering that can help you get started with that. So by no means are we saying that that's the only way you can start with Industry 4.0. There are folks who have clear idea that, hey, I have this problem. I see others using a particular technology to solve that problem. Can you help me implement that technology and do some problem solving on my side? And we routinely do that to kick off Industry 4.0 journey in a different way. So here you are starting with problem solving through technology adoption, generating some momentum, looking at the results, and implementing one of the more technologies to create some rhythm. So here are a few case studies on how people have done that. So here's a company, Allied Molded Products. They make electrical fixtures, enclosures, and they had a task which was picking a part up from a bin and orienting it in a certain way and putting it on a conveyor belt for next operations. So it was highly repetitive, ergonomically unfriendly. There was lack of employee engagement. The company had hard time finding qualified people. They were not really engaged in that kind of work. So they implemented a flexible collaborative robot to help that process automate. And now they have zero labor needed for the previously 100% manual task. They have better engagement and zero injuries. So the collaborative robot provides a synchronous vision enabled system for collision free motion planning. So that's one way they got started. Here's that robot in action. We have one in RIT. If you want to take a feel of how the cobot might help you, you're welcome to visit the campus anytime to look at it. So here's another example. Griffiths is a food company based out of Auckland, New Zealand. They had paper-based processes that were resulting into slowdowns, errors, and thereby razor-thin margins. So everything was paper-based: quality checks, safety checks, recipes, recipe alterations, and those reportings, are just not keeping up with the times. So they moved to digitizing production lines by connecting machinery to capture key performance data and displaying things in a unified way. So for example, biscuits are difficult to cook, so slight changes in humidity and temperature can cause unnecessary waste. So with real-time data regarding weight, temperature, humidity, and ingredients of the dough, teams can rapidly determine if dough meets quality standards or if it needs to, go to waste right at the beginning, instead of adding value to that product and then moving it to waste. So the operators are now better able to understand and improve throughput with increased visibility into asset health, operational efficiency, unplanned downtime, and insight into what works and what doesn't. So that has drastically improved Griffin's operation. Here's a dashboard that gives you an overview of what things look like in real time. So they have order information, they have production information, they have shift level view on what production does. They have a few trends that are critical for manufacturing. All this is in real time. A third case study here from a larger manufacturer, Daimler Trucks Asia. They had a problem of taking too long for resolving quality issues. And part of the problem was a discovery of the issues and investigation of the issues took a lot of time. So they created a big data platform to analyze previously siloed data and use some sophisticated algorithms to combine structured data like historical vehicle metrics and unstructured data like call center records, technician comments, and social media engagements. So all that was live, and that resulted into significant warranty cost savings, and they could prioritize and predict issues before they could happen, and that saved them 13 months in execution. So huge benefit. So here's a quick summary of how RIT generally helps with customer engagement. So we obviously can support your readiness assessment, your prioritization and strategic road mapping. We can also discuss different technology areas with your staff. We can review and compare different Industry 4.0 products on technical and economical parameters. We can help you identify and evaluate technology options to take advantage of those opportunities. We can support development and implementation of the projects as well. So really end-to-end assistance on your Industry 4.0 journey. So with that, let's move into this case study, which came out of one of our customers. Their name is Rich, Brilliant, and Willing, and they are into manufacturing of high quality LED lighting solutions. They're currently based in Brooklyn, New York, and they their lighting has been installed all over the world, including several Fortune 500 offices across the USA. Employ approximately 50 employees, and their business model is a combination of make in house and buy, assemble things, mostly a high mix, low volume kind of operation. So on this next slide, we have a few products that are samples of what they make. So really, things can differ quite a bit from product to product, and they have thousands and thousands of SKUs that can go into making their product. So why exactly did RBW choose Industry 4.0? So they had a staggering growth in revenue between 2018 and 2019, almost 90% growth. They already had an ERP system, an MES, a CRM, a CAD software, and they had a progressive, agile, tech-friendly work culture. All that was there, but there were a few things that were lacking. They did not have a cohesive strategy tying technology directly to business growth objectives. Their different software systems weren't fully integrated. So many things operated in silos, and where do we make the connections to have that seamless data fabric? So that was missing. All manufacturing operations were manual and they were pretty ripe for automation. So there were simple things that they could do to reduce their labor and increase their margins. So our team traveled to RBW's Brooklyn site and we reviewed all the organizational functions. We spoke with manufacturing operations, new product development, supply chain management, IT, HR, and frontline operators. We created, based on those interactions, a comprehensive assessment report recording all the observations and action items. So here are a few examples on what their project recommendations look like. So it was deemed that enterprise intelligence is one of the important dimensions for them to make some progress on. So they already had Tulip installed in-house. So one of the actions was to understand and highlight deviations in actual versus expected employee productivity using reporting data from Tulip, integrating business intelligence software like Power BI or Tableau for collating data sets and generating visualizations for key information. So they achieved all that growth, and that was generated without much of enterprise intelligence. With enterprise intelligence, they could take things to next level. Next thing we found important was standardizing shop floor automation related actions. So standardizing procedures to improve assembly work instructions, moving from simple text or papers to drawing images, videos, or AR based work instruction modules. Implementing automated quality assurance through vision-based automation. So all that was quite possible. There was vertical integration related actions. So establishing real-time connection between NetSuite, which was their ERP, and Tulip, which was their manufacturing execution system. Standardizing automated transfer of information between Onshape, which was their CAD software, and their ERP, which was NetSuite. Deploying Tulip apps, which was their MES, for sign-on, sign-off, quality control standards, and completion stages. And not everything was like super technical related stuff. There was organizational things that we recommended as well. So in workforce learning and development dimensions, they had to develop a mechanism for monitoring competency and improvement with a feedback loop to readjust learning objectives if necessary. Integrating learning and development initiatives with performance tracking in key areas. So this is just a sampling. We identified over 60 action items for them to complete in through the assessment, and the assessment took around about 3 days to complete. So it was really valuable for them to have a path forward with that is enabled through technology. So once the assessment was completed, it was combined with their income statement, with their KPIs and best-in-class assessment scores to create a prioritization matrix. So here's what the key outcome of the prioritization matrix looks like. Excuse me. So they have their assessment scores, they have P&L weightage, KPI weightage, and a proximity score that can then give them a data-driven approach on where should they focus first. And this is unique for RBW. It's unique for every organization that goes through an assessment. So it takes away all the pet projects and all the biases that people might have about what to do first, and it gives you an objective picture of where the progress should be made. So we took the prioritization framework and all the action items identified in the assessment, and we helped them create a 3 to 5 year strategy roadmap using a completely virtual tool called Mural. So in here we had 8 to 10 collaborators from their side. We have our own team on our side, and we looked at all action items, how they match with their existing strategy, which things in their current action item list align with what we identified in the assessment. We looked at each action item on a scale of benefit and value versus cost and effort. So whether it's high, medium, or low, and we did that through a multi-voting exercise. We classified those action items appropriately. We assigned owners, and then based on the bandwidth each owner has for Industry 4.0 actions, we laid them out in 3 to 5 year time span. They do their planning on a triennial basis. So which action items need to be completed first, which ones are dependent on the others. All that stuff was done virtually, and they now have a 3 to 5 year roadmap. So RBW is transitioning into a larger facility located in Kingston, and they have all these positions open to make progress with their Industry 4.0 journey. So more power to them and best wishes to them. So that concludes the case study, and we would be happy to answer any questions you have about the case study after the presentation is done. So one last thing here is we have a new engagement opportunity. We are kicking off a project which is funded by Department of Defense and via MXD USA, which is a Manufacturing USA Institute. So the goal of that project is build a web application that can take all the assessment work and give a user interface for manufacturers to do all those things on their own. So it would have a bunch of question and answers kind of interface, and it would give you a report of what your priorities should be. And it would be accompanied with specific case studies in IoT, analytics, manufacturing execution systems, automation to help manufacturers get started. So things begin on that project with a landscape survey. It's a 20-minute landscape survey, and I believe MACNY is on board to send you guys that survey so that you can give us some information how this web application should be developed. So there is an opportunity to contribute, and the participation ensures early access to all the project outcomes. So we would consult with you all who are interested to make the application better and more useful for your business. So in conclusion, Industry 4.0 is a fantastic enabler for drastically improving business operation and thereby competitiveness. RIT is here to assist with enterprise-wide Industry 4.0 kickoff. We are also here to assist with any projects that are going to solve your problems through technology. And there is this new MXD opportunity that we just discussed. This slide has my contact details. You're welcome to get in touch through any means possible, email, LinkedIn. We have a website that you guys can refer to. And that's pretty much the last slide I have on the presentation. Like Cindy mentioned, I have Dr. Thurston with me, and we would love to answer any questions you have at this point.
I wanted to first just mention one thing, that very important thing that Ajay forgot to mention during the presentation, and that is that we have funding from New York State and pending federal funding to support companies in this process. So in particular for assessments, those can be done at no cost to the company. And if there's a technology implementation project that comes out of that, those could be done with some minor cost share from the company, at least for the engineering effort. The grants we have don't support purchase of equipment or software for leave behind capability. So, you know, the funding we have really is intended to help companies like you at very low cost get started and on the path towards implementing this technology and improving your overall operational efficiency.
Everybody's stunned.
Or else they've forgotten they're on mute.
Yeah, you can unmute yourself, guys.
That's right.
Where do we sign up for the assessment, or how do we sign up for the assessment?
So it generally begins with an overview of the assessment for your broader team. And
Hey, Jay, why don't you go back to the slide that shows your contact information? So the short answer is just send Ajay an email and he'll start a dialogue with you.
Okay.
Or at the very least, you can also reach out to me and I know how to get a hold of him. So that would be fine too.
Sounds good.
so, Nick, though, just to give you an overview, it begins with an overview for your team. Then we visit the site if things are okay with respect to visitors, if you allow visitors, and then that translates into a pre-assessment questionnaire. And from then on, we can begin the assessment, and end to end from assessment through strategic roadmap building, things can happen within a couple weeks. So in 2 weeks, you can have a strategic roadmap.
Sounds good. Thanks.
Anybody else have any questions?
If you guys don't have questions, I can start some discussion and ask you questions.
There you go.
I have a quick one.
Sure.
I'm Bob with Morse Manufacturing, and personally, I do SolidWorks modeling, 3D, and so that clearly is the digital side of things. How does CAD CAM, is that just a tool in the cyber physical model? How does that tie in? What part does it play?
So it does play a big part with the product lifecycle integration piece, I think, because CAD/CAM really represents the true design data. That's the true north for design data, right? So there are many shops that may need process drawings for making. So say you have a turning section and the turning part goes to the heat treatment part goes to a grinding section for finishing within a tenth of 1,000. And usually what we see is that the crux of the issues manufacturing faces may lie with lack of availability of process drawings. So you're using the same drawing across several different processes, and all that is generated through your CAD, but you don't have maybe something like a PLM. And we can look into how you're using CAD, CAM, and PLM in unison to make the maximum impact. So I guess long answer to your question is we look at CAD as a tool that can integrate with other software systems. Mike, you have anything?
Yeah, a couple other points of integration maybe are as you look at electronic work instructions, those can take a lot of time to put together an effort. So being able to link your CAD system into that and also making sure that as changes are made on the design side, those changes are rapidly communicated to other parts of the organization. So the kind of the connectivity between different systems and also to your shop floor and to shop floor equipment is important to making sure that the work that's done in CAD CAM is properly communicated. And then even back to the customer side, if you're trying to, if you're doing kind of custom or engineer to order, being able to get that information quickly and in a streamlined way back to your customers is another element of that. Or potentially sometimes you may have to change the digital form based on, you know, the tools your customer uses. And some companies have challenges and kind of just basic data communication, especially smaller companies. So there are quite a few issues there that link into CAD.
That would apply to us. The communication and like you say, it's a daily challenge to get to get changes communicated and make sure things are, yeah, that's right.
So as Ajay mentioned, product lifecycle management is a class of software that's targeted to help with that. You know, though, like many manufacturing software systems, it's not inexpensive, and you know, it has to be integrated into your tools. So that would be something that, you know, we could look at kind of from a cost benefit standpoint in your case, if there was interest.
So
Ajay, in your experience, what is the reason companies don't take this path forward towards Industry 4.0?
sometimes it's just daunting. You have, a problem where people are working to improve their own KPIs in their own cadence and through traditional methods. There is just this whole burgeoning field that is simply unfamiliar. So lack of knowledge is one thing which I feel is common. Many a times people feel that Industry 4.0 transformations need to be big, and it's a huge investment that I have to make, but I think that's not true. You can start small and you can gain some momentum. There are companies that don't have a cohesive, direction which combines leadership and workforce. So there are cultural aspects that can prevent companies from moving forward with Industry 4.0. So there are a few problems that come to the fore, and some folks are simply thinking still not really something I need to engage in because it might be a fad and it might be going away. But we strongly feel that it's going to be here and we should adopt things as quickly as we can. In fact, all nations across the developed world have a strategy for is to have a strong transition assistance program for small and medium scale enterprises.
I think there's some other issues we run into with advanced manufacturing technology integration, and you know, this may not describe you guys, but we find that when things are bad, there's not the resources to take on forward-looking projects like this, and when things are good, you're so busy trying to meet orders that you don't have time to do it. So, you know, there's never a good time that's convenient. So it has to be kind of either an emergency where, you know, you can't find labor and you need a robot, or a more strategic kind of approach. Other problems that are some of our projects are trying to address is that there's not a lot of good information out there about what the return on investment for some of these things are. So in each case, it takes a lot of effort to try to assess that. So we're trying to get better case studies that represent, you know, small to medium-sized companies. So, and also a better framework for estimating return on investment. Integration is also a challenge because you have a lot of software systems that you have investment in, and kind of trying to piece these things together, or to, you know, let's say your ERP system is a little bit antiquated and you need a new one to take the next step. That's a huge effort and a huge investment, right? And all the points of connectivity have to be addressed. So those are all barriers, and, you know, looking at it kind of over a longer period of time, hopefully you can, you know, find some strategic, slow pathways towards improvement without trying to eat the elephant all at the same time.
So anything else? Looks like we're right at about 2 minutes till 10. So good job on timing. I appreciate that. Certainly, if you think of questions after we have departed here today, you can send them to me or directly to the team at RIT. I did put in chat, if you guys saw, we are recording this, so you'll all get a copy of it as well. So if there's something you weren't taking notes fast enough, you'll be able to go back and capture them later. So, and we thank you all for coming, and thank you very much, Ajay, for the great presentation. Appreciate it.
Thank you, Cindy.
Hey, Cindy, I just wanted to make one more closing comment. You know,
Okay.
I kind of mentioned it before, but you know, we're funded by the state to work with companies to make them more competitive, and you know, no questions too big or too small, and no questions dumb. If you just want to chat over, you know, your situation, whether it's general or specific, you know, we're here for that. And there's many other resources for specific things throughout the state, you know, in university-based centers that, you know, if it's something that we can't do, we can maybe point you towards a resource that can help you with your question. So
Might as well leverage your tax dollars,
yeah.
right?
Thanks, Cindy. This
Thank
was
you.
great.
Appreciate it,
Thank
guys.
you, everybody,
Thanks
for-
again, everyone.
Thank you.
Thanks, guys.